This video is going to talk about independent and dependent events and odds. So, when the outcome of one event does not affect the outcome of a second event, the two events are said to be independent. But if the outcome of one event does affect the outcome of a second event, the two events are said to be dependent. So, they give you guys some examples, and it wants you to decide if they would be independent or dependent of each other. So if you roll a number cube and then toss a coin. So is the outcome of either one of them dependent upon the other one? If they're two completely separate items, they're not going to affect each other at all. So rolling a number cube and tossing a coin are going to be independent. So, picking a marble from a bag, don't replace it, then pick a second marble from the bag. Okay, we'll think about this for a second. If you have 10 marbles, you pick one of those marbles out. Is the probability or the chance of picking your next marble now going to be better or worse now that there's less marbles in there? The probability or the chances are changing because now you have less marbles to choose from. So picking that second marble is actually dependent upon whatever that first marble was that you picked. So that's going to be dependent. Here it says list an example of two independent events and then give an example of two dependent events. So this could really be anything, guys. So if you want to pause this video and think of something, write them down. So you need two events. So again, independent means they have nothing to do with each other, and dependent means that the outcome of one is going to be dependent upon what you did for the first event. So get two examples for each of those. Okay, so those would be my examples if I had to write them down. So those are just two examples. Yours don't have to match mine if you thought up of your own. Sorry, thought I was going to sneeze there for a second. If you guys did think up your own examples and you want to check just to make sure that you did them correctly, you can. But as long as your independents don't affect each other and your dependents would affect each other, then you should be good to go. So try the bottom half of that page, guys, and I'm going to switch page. And now it's actually talking about the probability of independent and dependent events. So for two independent events, A and B, the probability that both events occur is the product of the probabilities of the event. So if A and B are independent of each other, the probability of both of those events happening would just be the probability of A times the probability of B. What about dependent events? Okay. Well, for two dependent events, A and B, the probability that both occur is the product of the probability of the first event and the conditional probability of the second event given the first event. So, we talked about conditional probability in the last lesson. So you would take the probability of the first one and multiply it by the conditional probability of the second event. So we will look at an example of that. But let's look at the first one here. Sorry, I have the sniffles, guys. As part of a board game, you need to spin the spinner at right, which is divided into equal parts. Find the probability that you get 25 on your first spin and 50 on your second spin. Okay. Well, if you're spinning this spinner, guys, is your probability or likelihood of getting an 8 on a second spin going to be changed by a first spin. You're not taking anything away from it. You're literally just spinning it the first time. Okay, nothing's changed. Spin it again. So this is going to be independent. So you really just have to multiply the probability of getting a 25, which is 2 out of the 8 sections, times 50 has 1 section. So 2 over 64, which is going to be 1 over 32 reduced. And that equals about 3%. So the independent events are pretty easy, guys. So for example, number 2, it says a bowl contains 36 green grapes and 14 purple grapes. So 36 and 14 is going to give us 50 total grapes. And it says that you randomly choose a grape, eat it, and randomly choose another grape. Find the probability that both events A and B will occur. Okay, so event A is that the first grape is green, and then event B would be that the second grape is also green. The first one you eat is green, and then the second one you would eat is green. So, what's the probability that the first grape we pick out to eat is green? How many green grapes are there in the bowl? There are 36. So 36 out of 50. But this situation is not independent, guys. That second grape you choose, the probability of what the color of that grape is going to be is dependent upon the color of the first one that you choose. Because when you took that first grape out, that grape is gone now. So you have less grapes in that bowl than what you started with. So yes, the first one is possible to get 36 out of 50. But now that you've taken one out of the bowl, you only have 49 left. And if that first grape was green, you don't have 36 left. You have 35. So it is 36 times 35 over 50 times 49. And you get 1260 over 2450, which reduces to 18 over 35, which is about 51% chance that the first grape you will pick is green and the second grape you pick is green. So you guys go ahead and try number 1 and number 2 at the bottom there. So just remember to be paying attention to see if your problem is independent or dependent.